Hello everyone, how are you doing? So today we thought of making a text detection system. I had this weird dream and a nightmare where I thought, one fine day you're getting up and you're not able to read text. So I was scared and I thought how great it would be to make a text detection system. So today, without much ado, we're going to look into and see how we can make a text detection system. Let me open up the program I have here. This is how it's going to be looking like. So this is how it's going to be looking like. Let's close this. This is how we have the text detection algorithm. So today what we're going to do is go over this EAST, which is an efficient, accurate scene text detector, and it is by these gentlemen from China. So the team made this very nice and very efficient text detection system. It's probably one of the best out there. And pyimagesearch.com, Adrian from PyImageSearch, he made a very good tutorial on this as well. And I'm using parts of the code from him and parts of the code from OpenCV's GitHub account as well. So it's going to be a combination of both of them, but both OpenCV's text detection system and Adrian's system is using this paper's application. So it's a very nice text detection system, and it's a very robust system. We'll see in a little bit and test it out in our real scene scenario. And I've looked into it. It's really, really good. So to be honest, my real project down the lane is to develop a text recognition system which could be paired with Alexa in a very robust form. I made this one in the past, but it wasn't as robust as I want. So we're working on finding the most robust and most accurate way of finding this text detection system, and hopefully make it online for everyone else to use, especially during this time of quarantine when things are getting very backed up. Students, and especially people with special needs and people who are not able to, who are visually impaired, they are not able to read there, and they don't have the proper logistics. No one was ready for what happened. So people, especially with parents who are having special needs children and the visually impaired, they're having difficulty in reading textbooks and having the child read those textbooks and this audio version of their text. So the idea is going to be help make a text recognition system that could read the text online, and this is the first step in finding the most robust text detection system. And here we go into the code and explain how this code works so that you can implement it on yourself. Now, as I said, it's part of Adrian pyimagesearch.com. I'll put the link to his website in the description below. So I'm using some of these import libraries, and the one on top, iMutil's object detection non-max suppression. This is nothing but his open source non-max suppression system which we are using. OpenCV has its own non-maxima suppression. I'll go into detail later what it is, but OpenCV has its own, but I found that it's a little bit slow and it's not too efficient compared to the one which he made. So I chose to use his over OpenCV's, and we'll see later on in the program how it's being used. So we are importing these four libraries: NumPy, Time, CV2, and import. So we're coming down here and we are capturing the video. So I wanted to do text detection on a video, so we are capturing the video from the video capture, and this is the camera. You can put down whatever camera you're using. You can put on 0 for the default camera. You can put on 1, which is the next camera, 2, which is the second, third camera, so on and so forth. So that way you can define which camera you want to use if you have multiple cameras connected to your computer. Then this is the main library. This is the main brain of the whole program, and it is nothing but the neural network which the East detection people, which these guys developed, and this is their the frozen neural network library, which we are going to be using in order to detect our systems. So they collected a wide variety of images, and I'll show the paper back again, and we'll go later in the bottom. So you'll see they collected wide variety of images, and they explained and they trained their system, which could take care of so many different types of orientations, zoom, shape, and see it's able to read the text out of the t-shirt, bus, boards, even the most minute, which is not even properly illuminated or regularly illuminated. Everything is being read very carefully, very nicely. So these guys did a very good job. They collected a lot of images and trained their system to detect these images, or bounding boxes out of for the text detection. So we're going to be using their text detection system from here, and I have this while loop open so that I could continuously read the image coming out of the webcam. So it's a real seamless process, and I'm reading the image and storing it into image. Hash frame is nothing but a flag which lets you know whether or not the image was captured, and I'm saving that image in this original file. And the reason I'm doing that is because we're going to do all the computation on this, and we're going to do a lot of changes in this, and those changes are required in order to feed the text detection system. You will see later down we need to pre-process before we can send it to their neural network, because that's how they had designed it. So we want the images to be formatted in the same format, in the same way which those guys had designed. So we will be doing that in order for us not to lose the original format. We are saving it and we are keeping it safe so that we can use it down the lane once everything is done. So just remember this, and we're saving the image shape into H and W. The reason we're doing that is because we have to format the image into a factor of 320, because that is what these guys had used. So it was a factor of 32 to correct myself, and the image width and the image height should be a multiple of 32, and that's the reason you will see I've used a width of 640 and a height of 320, which are both multiples of 32, and that is important because that is what they had used, and their algorithm or their neural network, which is this one here, is running on. So we want to make sure we are having the same factor in our images, and this is nothing but making sure if it is 320 or 32 or not, and how much they should be changing. So it's not so much of use as long as you're making sure it's 32 based. And I'm resizing the image into a 640 by 320 here, and these are 2 layers. So what are these? This is again something to do with how the East algorithm was trained, and their neural network gives out 2 outputs. One is the score, which gives out the score of or the confidence of the text which was detected, and the second is nothing but the geometry. So how is the text oriented, whether it is horizontal, a little slant. So we've seen in the paper they have different types of text, and different orientations, different it has all types of orientations in it. So this orientation information is stored in the other layer, which is the geometry. We'll see here how geometry and scores are being used from the neural network. So we want to define that here, and this is how they had defined. So we're going to be doing the same thing, and coming down here. So this is the first step. This is the first most important step, apart from making the image a multiple of 32. This is called as blob from image. Now, what is this? So this is a very interesting application, and it's part of the neural network library of OpenCV. So what it does is, say someone has made a neural network and someone has made a training algorithm, and they used their own images. But if for someone else to use that same trained neural network, they want to make sure the images which these guys are going to be using, or the environment where they are going to be testing, has the same type of image, has the same amount of brightness or the saturation, or the effects in the images are same as the effects which were there in the original training data set, if it makes sense. So if you have any doubts, leave a comment in the below and I'll be happy to explain it to you. But the basic phenomena of this blob from image is nothing but to first identify the mean of your image. So you have the RGB values, and that's how the image is made up of, and you are doing nothing but identifying the mean of that image. So what is the mean of R? In this case, it is 124, 115, 106, and if you subtract that, you get this type of an image, which is free from the influence of brightness, the influence of color. There is light or no light, it doesn't matter for that. And if you have images of this type, then it helps anyone in the future who's going to be using your trained neural network to use your library on their own image sets. So that way it is on the same, we're defining the ground truth for the image detection. And here, what you see here, 123.68, these numbers, these are nothing but the RGB values, or the mean of those RGB values, which those initial guys from the East paper had used. So we want to be using the same mean values which they had used, and it's important to use the same exact numbers and make sure we are doing the same, so that our images also are also being subtracted from the same mean. And once we do that, we're swapping the RB. It's just because if you see here RGB, OpenCV has a different format. It assumes that it's BGR. So by swapping, we're doing nothing but changing R to B and B to R. So we want to do that so that we are defining the exact amount of the correct value of B and R. And in order to do that, we are just swapping RB. If you want to avoid this, you do nothing but replace 103 by 123.68 and put the 103.94 in this place. So you're just swapping this guy here to this guy here. That's about it. And we want to put crop false, so that way we are not cropping the image. Once we're done, once we define the blob, we are using the set input, so that we use that in order to subtract our image with the same mean from the East data set. Once we're done with that, we give it to the neural network using those layer names, and it gives out these two geometries, these two information. One is the scores and one is the geometry. So we spoke about this in the beginning. The neural network which they have defined, the task of that neural network is give out these two information. One is the geometry of where this text is present, in what direction or what orientation it is, and this defines the score, so how confident it is about that particular thing being a text or not. We're going to be using that and defining where to draw our text detection systems, uh, bounding boxes or not. So once we do that, we are coming down here with this is nothing but just defining the number of columns and number of rows in our image shape. So this is nothing but the shape which we had defined here, and the scores which we have. We're just making sure we know the number of rows and columns, so we run through across all the scores. Once we are here, we then go into the number of rows and we go through all the scores and all the scores horizontally and all the scores vertically, and we use the geometry of that information. So it's nothing but identifying where these text detections are. So it's nothing complicated. As long as you're using this, you will get an idea of how this is being used in order to draw those text boxes on your images. Come down here. Here we're making use of a little bit of geometry and these cosine and angle functions. The reason we're using that is so that we know in this particular section we saw how these text boxes are slanted, obscured, or skewed. So there are different orientations, and in order to define how the boxes are going to be drawn, we want the information in terms of the angle data. And this is also being present from the geometry information of their, the neural network which those guys have made. So coming down here, we are going to be drawing the text boxes, and we are using this function, and we're defining the start and end points using the end x, start x, start y, and end x. So these are nothing but just defining where the boxes, where exactly the boxes are. And this rect function is nothing but using the uh, coordinates which we had defined earlier and making the rectangle box. And this confidence is nothing but using the scores data which this function, this neural network had spitting out, and it's taking those confidence score which we are going to be using in order to identify how strong or how confident the neural network was in order to detect that text detection. So we just use text detection, and this is that function. This is that non-maxima suppression. So what this function is doing is um, many a times, so image detection is not a very accurate system. It's based on a lot of trial and error, and there are many times that there will be noise in the image which can make your detection system not work properly, and a result of which what will happen is there will be many cases. So I found this paper on learning non-maximum suppression. So if you see on the image on this side, you'll notice that there are a lot of bounding boxes on this. So it's trying to do a people detection, and it's detecting so many boxes, so many bounding boxes, which are all erroneous. And if we were to detect, it would say that there are maybe hundreds and thousands of people sitting here if you count the number of boxes. But that's not true. There are only 5 or 6 people sitting here. So we want to make sure we are using the most confident box and not using everyone else. So that way we don't go into unnecessary counting. So by using non-maximum suppression, it suppresses all the lower scored values and uses the most confident score only. And once we do that, it gives out the box dimension, and you're going to be using only those boxes which are very confident. And once we do that, we're doing nothing but using this information from the rect of the boxes, which is the rectangle information on the boxes, and drawing the rectangle. And we're drawing it on the original image. So we're not drawing on the processed image, but we're drawing on the original image which we had stored from here. In the earlier of our while loop we had stored. So we are going to be using that image, and we're going to draw the rectangle on that image so it looks like it was drawn on the the original image that was feeded. Once we do that, we are going to be showing it using the CV2 function, and it will show up on the text detection video. Now this is nothing but the wait function. We need that in order for us to display the image using the IM_show function here. And once everything is done, I could just press the escape button, or Q, I think, or maybe escape button in this case only. And for the moment I done, it destroys all the windows and it releases my webcam so it can be used for something else. So I'm going to run this program now, and this is going to pop up a window which is going to be focusing from my camera. So I have my camera and I have placed a book in front of it, and it's trying to extract all the locations of the text on it. So you can see that it's to the most part it's good. The reason we are not seeing all the functions is because the book is placed slantly, but for the clarity or the type of webcam I'm using and the brightness I have here, it's decent enough and it's giving out the right text detection. So I'll try to move the camera to a different poster here on the wall. There is some lag here because my processing power on my computer is not the best, but now if you see, it's able to detect all these minute words which are present on the wall, and we can see how even if it's not oriented in the right straight or perpendicular to the camera, but still it's able to read all those texts, which is very good for us, and that's what we need in order to move forward with our project. So with that, I come to the conclusion of the text detection system. If you like my videos, and if you like the journey, or if you are into computer vision or AI or IoT or embedded systems in robotics, this is something where I'm going to be testing and posting on, publishing all my projects, so that it keeps me in check and keeps me up to date with what is going on in this field. So if you are interested, subscribe to the channel, and let me know if there is anything else you want me to work on, or if you have any questions related to this particular project, please leave a comment below and I'll be happy to help you. Until then, have a good day and stay safe.